Hi, I'm Justin from Beacon Platform, and today I'll show you how easy it is to integrate Beacon with Symphony, and hopefully convince you that the two platforms are complementary and in fact essential to streaming workflows that involve an element of real-time communication. Financial institutions use Beacon for trading and risk management, pricing and analytics, workflow automation, and more. If you're interested in learning more about Beacon, check out the website here. If you want to know more about the Symphony API, you can check it out here. Beacon comes with Python libraries that allow developers to programmatically post to Symphony and create event handlers within Beacon. It also comes with a settings and secrets manager that stores the necessary details for connecting to the Symphony pod, so developers can focus on the business logic of the workflow they want to streamline. In this session, I'll show you how to set up a bot in Symphony using Beacon, and show you how easy it is to implement a rules-based bot in Beacon. Now that we have our IDE running, you might see a development environment that looks familiar to you. This is the IDE version of VS Code with integrations to our different applications and infrastructure. I've sized my screen to show my IDE on the left and the Symphony chats client to the right. I've set up a simple Hello World demo to get us acquainted to our integration library with Symphony, and will live code this with you. We have a getBot client function and a message poster class imported into our environment to start with this Hello World application. First, I'll start with creating a client that connects to the Symphony API by using getBot client. We'll see here that it takes a profile as an argument, and we'll use default as the argument. Profiles can be defined to give a bot a particular kind of access to the platform, and these profiles can be made accessible to specific users for security control. The credentials to access the Symphony platform are stored in a secrets management system, so developers do not need to worry about managing their own credentials to the Symphony client. Next, I'll instantiate a message poster. It takes the room name and a bot client as arguments. And as the open chat has demo as the room name, we'll use demo. Now that the message poster has been instantiated, a message can be sent to the chat room. And the message will be hello chat. So we have a 5-line example over here that's able to send a message to the chat room. More complicated messages can be sent by adding HTML. So we've added a header to the message. In addition, not just headers, full forms can also be sent to the chat. And we'll copy paste a larger message out. So this gives a simple example of how quickly it is to create a Symphony chat poster using the Beacon library. For the next part of the demo, I'll be implementing a simple rules-based bot that will respond to messages from users in the chat room. I've imported some libraries in advance at the top of my Python program, and we'll go through these as we use them in the demo. So far in this program, I've defined a demo processor, which inherits from a simple processor class that will be the processing engine. By default, it'll be watching the demo chat room. Inside the demo processor, a rules class variable has been set as a blank list. I'll be adding processing rules to this as they're created. Below this is a getProcessor function that takes in a bot client object like we've seen from our previous demo. Finally, we have a run section at the bottom where a Symphony bot server is created and the profile is set to default. The next string tells the server to use this module to run. The bot server will use the getProcessor function to launch this bot. When starting the server, a context called a Bob state is created. This provides state feedback to our batch management system when the server started if it is running from our batch management system. As I'll be running this from our IDE, there will be no impact to our batch management system. To start this demo, I'll start with creating a simple greetings rule to have the bot respond from our greetings command. I'll also inherit from a regex rule class. Inside of this class, I'll define a regex rule variable. This variable will be used to match against the message that we want. Next, I'll define a process match function. This function will take the message as the input and also a regex match object. The return value will be the string that is sent back to the user. Now that the rule has been created, I'll add it to the demo processor. Now that the bot is ready, I'll run the bot and run the greeting command from the chat. We see here that the bot knows who I am and has responded back with the contents of the string in addition to the value of the regex group. I will next extend the regex match to include a string capture group and show the captured string can be used as input to other processing functions. The bot can now be restarted for the rule to take effect. I'll next send the greeting message to the bot. Now the bot responds with the full message and only the captured component of this message. For the final part of this demo, I'll add a quote rule that will print the price of a commodity. As this is more complicated, I've prepared this class in advance. After adding this class, I can restart the bot to make it active. I'll next send a quote request and the bot will respond back with a price. To describe this example a little bit further, we will take a look at the quote rule. Inside of the quote rule, we see that the regex variable has been set to capture a quote command in addition to a capture string. This capture string is parsed by a function which is used to extract an instrument under a assets energy market hierarchy. Once the instrument has been extracted, the instrument properties are then extracted and put into a template string. This template string is then relayed back to the chat, which contains information about the price. Further information about these instruments can be explored by using a Beacon database explorer to find additional instruments. I have now stopped the bot, and I will launch the integrated Beacon browser from the IDE to find additional instruments. Once the Beacon browser is now running, I am able to select the database, and from here I can follow the hierarchy to find the instruments. After following the assets energy hierarchy, we can see the list of instruments. Let's take a look at one of these instruments. This instrument in particular is a CME New York Harbor Ultra Low Sulfur Diesel Future. We can go back to the bot and see about pricing this instrument. I will now restart the bot and grab a quote for this instrument. By the end of this video, we see how easy it is to quickly communicate with Symphony through a simple posting application and moved on to creating a bot that leveraged Beacon's integrated financial instruments and a database browser to quote back commodities prices. These are just a few of the advantages of working in an integrated environment. I hope this demo inspires some ideas about working with Symphony through the Beacon platform. Thank you very much for watching this video.